My name is Jonathan Sanders, and I'm obviously from Missouri S&T. I'll be doing the first half of this. Since we're the first to go up, what I'm going to be talking about is successful team structure and focus for particularly new teams that are thinking about joining the ASME competition. And I'm going to be, like I said, I'm going to be focusing on team focus and team structure. And it's, as far as team focus goes, every team is unique and operates, throughout its design so differently. But there's a few similarities amongst the really successful teams when they're the consistently successful teams. One of the things that new teams should focus on is how to keep members involved and interested, and how to attract new members rather than focusing on the actual product itself. When you consistently, are competitive, it's because you're gaining from a knowledge base. You have a lot of experience that you're coming from, and that comes from that comes from members coming back and bringing the knowledge that they have with them. Older members, they tend to bring experience and higher knowledge with them, and they're able to incorporate more complex and efficient systems into your vehicle. And they also serve as great mentors towards your younger members, which eventually will take their place. And your younger members, they tend to bring a new kind of look at ways to tackle a problem versus the older members who may have kind of gotten into a kind of similar process for solving problems. And they're also a very valuable workforce, so that's why it's really important to have them around. So, and by doing that, by attracting new members and keeping your current ones active and involved, you have a constantly expanding knowledge base that you're able to build and grow on. And because of that, you get a better and better product from year to year because you're building from that experience. As far as team structure goes, again, every team is unique, and it runs on a different organizational structure. Some are really strict in their decision-making policies. They have a very strict hierarchy, and it follows that. Some are very loose and free-flowing with their ideas, and they tend to bounce around ideas a lot, and it changes, and it's very free-flowing. And each one is, it depends on each team which one works. But there are some things that are pretty key to a successful team that you do need to have incorporated into your team structure. And one is you need to have assigned team leaders for different aspects of your team, which would be your manufacturing, your design, your finances. And the reason for that is you can organize all of your information and ideas, and they can go to a correct person who can get them where they need to go. And then how you elect those leaders is also up to your team. Some people elect them, some people have them grandfathered in terms of their age and their experience. The other one is you need a system for conflict resolution. Problems are going to happen. You cannot avoid it. It just happens. And so having a system for solving problems quickly and efficiently is very, very key to making sure that your vehicle production goes forward. Now, it's certainly acceptable to have different forms of systems within your team. You may have a system for solving problems on your manufacturing portion and a different system for, say, your finances or your public relations, and because one works better for the other. And there are different examples that you can do a team vote, or you can do executive decision based on your leaders' positions. But it's certainly something that you need to have in your team. I'm going to let Ross take over here for design and manufacturing approach. He's actually our lead engineer for this year. So.
All right. Thank you, John. I'm just going to kind of go over tips and tricks, just general things to try to follow when you're designing and manufacturing one of these bikes, especially if it's your first time doing it. So you have to start somewhere. So you want to make something you want to ride. So don't go out and make something that just fits with the group. Bring some enthusiasm to the plate. If you make something you want to ride, it's going to be a good product. Take some bite-sized chunks, because when you try to make innovation, everything takes time, and we're on a 1-year build cycle. You have to design, test, and manufacture that to a level where it's going to work under under these racing conditions. So try to make progress, but make it reasonable with the size of your team, your experience, and all that. And use your members' practical knowledge to your advantage. You know, if you have team members that are extremely experienced in composites or something like that, you know, go forward in that. Or if you have a team full of machinists, make a giant chunk of metal that'll go fast. So, and you know, it all starts at the competition. So teams coming out here making prospective runs are definitely going to advance teams that are just kind of throwing into it, because you can definitely take hints from other teams at competition and use them to your advantage for sparking new ideas. And you can look at see what works well and what doesn't in the races. I mean, I'm sure we'll find out a lot of different things tomorrow in the endurance race. And it seems like if it works really well, chances the judges are probably going to see it the same way. So you can probably see, you can kind of maybe a little bit predict what you'll see for the next year. Use that design direction that you learn from that competition to basically push forward your design earlier. So a practice I know our school tries to do every year is to have basically a large portion of the bike designed before you even get to the school year, so you can have more time to work on actually manufacturing it and tooling out all the problems. And use a structured system. Starting out with a way to compare your vehicle to previous ones, or even just something else you've seen out there that you think is really cool. Just a way to keep good aspects and get rid of the bad ones. To keep progress moving, and make prototypes. Make a proof of concept before you go all in, and spend all your time making something that may or may not work. And one rule we've always kind of tried to follow but doesn't always happen is plan to test for 4 weeks. So you find a lot of big problems and things go wrong. I mean, we're blowing out bearings today, and it's always a fun time. So, and then like another thing is how to progress once you've started to build a bike, how to become more competitive, is to try to use more solid modeling and analysis. Basically, you're able to streamline your design process and basically be able to know what your design is going to do before you go out there. Use actual engineering practices to design these things, because there's a lot of things that a lot of teams go out there with parts that are overbuilt that can be brought down. A lot of pieces that are built that are nowhere near what they need to be. And if you can figure that out earlier by using modeling, you'll be able to get rid of these issues. And from our team's experience, I mean, we've been around for a long time. Basically all the older members that I've ever heard tell me is always make a well-oiled machine. It may not have to be the fanciest thing out there. It doesn't have to be the fastest thing out there, but if it keeps riding, you will do well. So, because a lot of times if you have a breakdown, I mean, you're out of the race, it's done. So it's a big thing to have a vehicle that'll continue working. And keep pushing yourself. So don't try to get stuck in a corner. If you seem like you're building the same thing year after year, or the design isn't really working, try to branch out, try something new, use prototypes to develop it, and you can be able to still become more competitive with a different style of vehicle, or a different type of part, or landing gear, or crank arm, or something like that. And one last part is if you're having issues and you can't really work it out, try to make a stopping point on a design. Hey, we're not going to make it in time. We should probably make a backup for this and go ahead and make something so we can still compete and have a vehicle, and you can still have a good race without some of your more advanced technologies. And then the last one, avoid dumb mistakes. So basically, like John was talking about, was pass down your ideas to each team members. So make a cheat sheet, make a 1, 2, 3 list on how to do like a seat layup or something like that, or maybe how you structure your design process. Use your, make a structure, make it so you can't make the mistakes of years past. Educate your members of different problems you've had before. And then, lastly, just keep all that in order. So that's it. Do you have any questions?
I'm curious, you're talking about conflict resolution systems.
Yeah.
What such systems do you use or have you seen that they're effective?
One thing that works on our team well, we actually have a combination of a team vote and a leadership decision generally, if it's something that we tend to stay stuck on. So what we will do is we will pull several members working on that particular project, and we will have fairly lengthy discussions about it, weighing the pros and cons, and if we still can't make a final decision after that based on what we've discussed, we will eventually leave it up to the project leader's decision. Oh, yeah, absolutely.
All right, any other questions? Nap time?
Yeah, go for it, Victor.
How do you keep track of these cheat sheets? How do you force people to actually write things?
Basically, what we've done is, as a lead engineer, a person who does all the design, we encourage them to, while you're designing it, just make notes of what you're doing, and then we have a large file system that we pass down to each person who's doing that type of design. So you can look through there and you can have them study it over the summer, or even talk to it, and it's something to refer to. If you have a question, you should be able to go back into some document from who knows when, and you might hopefully be able to find a solution, and realize why somebody made a decision the way they did.
Yeah.
So.
And keeping track of that, of the cheat sheets and the data is really something that the older members should try to instill in the younger members. It's just one of those things where they mentor them. It should be a good practice for them to instill in the younger members so it consistently stays with the team. Go for it.
Well, stickers on the side of your vehicle. Wonder if you can say anything about getting sponsors.
As far as sponsors goes, there's many different approaches for getting sponsors, but that's kind of a tough question.
I think
do you think you can make it maybe a little more specific?
How much time do you spend on getting sponsors, and how much has it been worthwhile the time you spent on getting them?
We actually spend probably all year round looking for sponsors or looking for potential sponsors. The bulk of our time looking for sponsors actually happens during the first half of the design process, because of the way most companies their quarters line up with the fiscal year, as well as with our build cycle. They generally are more reluctant to donate to a team during the first half of the design cycle, and it definitely has been worth spending time on. There is a lot you can save on your budget, and there's a lot of material that you can save on. But something that's probably the most valuable as far as talking to sponsors, if they sponsor you, a lot of times there are industry experts that are willing to work with you how to use that material, or things that you may not know that they do, that allows you to create an even better product.
Another way we get more sponsors is honestly instilling, like we make a requirement for our team members, if they want to go to competition, to raise a certain amount of money from sponsors. Not necessarily that they put in money, but that we have them go out and on their own go talk to sponsors. And another thing is you can it really is, it's not that hard, because a lot of companies really want to donate to something, a learning experience like this, because they see it as potential for new engineers for their program, or for their company, and they really like that progressing.
Yeah, I could probably say that the biggest tip for looking when you're planning to talk to a sponsor is just being well prepared for what you're going to say, what you need, what you're asking for, and how you're planning to work with them.
Different teams from different schools get a wide range of levels of support from their own schools. Would you mind sharing with us, in your budget, how much comes from the university and how much comes from your own fundraising?
I think we, like,
Trying to remember the numbers right now.
I think they pledge roughly like probably around 20%, but to get that full 20, you know, it's not necessarily 20% of our budget, you know, they pledge it according to our projection needs, and it's not, you know, but we do have to actually physically raise at least half of that money where they'll, you know, they'll do a match. So it's not just they'll give us money, they do a matching with our fundraising.
The way that our particular department works that houses our design teams is actually we submit an annual request, I guess you say.
Team proposal.
Yeah, team proposal. It's a very, very long, detailed proposal of the proposed design year, and we are competing literally with all the other design teams under the department, and the staff there that are in charge of allocating these funds go and judge these proposals as well as what they think they will need and allocate that way. And another way that they have to keep us in track with our deadlines is that they only allocate so much at a time based on if we're meeting our deadlines or not. So.
And our goals.
At your school, are you, is this a senior design project? Is it a class? Is it a club? How is it structured?
I guess you could say it is the closest to a club. I mean, we are called a design team at the school, but it's all volunteer based. So you get out of it what you put into it. So everything that we do is based off of our own free time.
Do you get credit for it? Do you get credit hours?
We do not get credit hours. What we are recently working with one of the departments with is getting it on our transcript, showing that we were on a design team, and if we were on a leadership position, that we had a leadership position there. So it does give us a little bit of credibility, like if we're interning for someone, they can have a way to check that.
How long did it take to complete the project?
We started, well, I guess we started design last year. I mean, at last competition, we're sitting bantering about all the different things we could do, and then we started focusing down over the summer. So design was about, I'd say about 70% done by the start of the year, and then we started going into final design phases and prototyping the first semester, and then second semester was implementing all of that, and so it was about a semester time to make the final product.
Now, if I ask you how much new compared to old last year, you also have seen
Physical components, like what we actually
design-wise, is it
completely new? Yeah, there's I don't think there's anything on there that is. I mean, a lot of it resembles past years. It's a lot of refinement, but nothing is completely just copied and brought over from last year. We do that on occasion, but we typically like to refine since we like to make complete whole new bikes that we can ride.
Yeah, generally, we seem to go through a 2-year pattern of an innovation year, which would have for us would have been last year, switching over to utility class, and then a refinement year of the previous ideas, and then we'll go back into an innovation year. Yep.